Hi, it's Tony Fold here. This video is about how I modified these DC motors which have come out of a treadmill. Now these motors are very popular amongst do-it-yourself machinists because they're normally available quite cheaply from scrapyards. Many people use them for powering grinding machines such as a tool post grinder on a lathe. This piece serves three purposes. It's got grooves on here for a poly V belt to drive whatever you're driving with it. It's cast iron, it's got quite a bit of mass in, so it acts as a flywheel. Both those two things are good. But the thing that's bad for our use in a grinder is this also acts like a fan to draw air all the way through here. Now the holes at this end, there's two of them, are to let air in, which is sucked all the way past. Now the problem with use as a grinder is we've got a lot of steel dust in the air, and there are very powerful magnets on the inside of this. So what happens, the fan sucks the steel dust laden air in through here, which then gets stuck on the magnets and will eventually clog it up. Now in its normal use on a treadmill, of course we don't have that iron dust in the atmosphere. So the first thing we've got to do is to get rid of this fan. Now every one of these that I've ever come across has this screwed on with a left-hand thread. So if ever you're going to dismantle one, remember or try first that it's likely to have a left-handed thread. So just take that off, and then we're left with a shaft which we can put a pulley on to drive our grinder or whatever. Now I'll dismantle this off camera, and then we can look at all the individual bits and see what we can do to improve it for use as a grinder. But not only just as a grinder, a lot of people use these to drive other things in the workshop, small lathes, drilling machines, etc. These are all permanent magnet DC motors, and that means that the speed can be adjusted by adjusting the input voltage. The no load speed is directly proportional to the input voltage. Okay, so motors now dismantled, you can get a better look at the fan aspect of the flywheel that we were looking at before. Put that to one side. This is the main motor housing. Now I think you can probably see in here there are two curved magnets, ferrite type magnets, so they're quite strong, and they're the ones that will catch any magnetic type of dust that's passing through the motor. This is the end cap which fits on this end of the motor, and it serves three purposes. One is as a support for the bearing, the other is a support for the motor brushes, which we can see here. They were riveted with two rivets onto raised pieces on here, and the third function of that plate is just to provide a cap on the end of the motor casing. I'll remove the brush assembly from there, and we can have a closer look at this. Now you can see that this is just a piece of probably 1.5mm pressed steel, hardly a precision part for something that's got to hold a bearing. And also you can probably see here that it's not a terribly tight fit on the bearing. I can just push it on and pull it off, so the bearing's not located very well. Also, to locate in here centrally, it's just got a few little indentations on this which weren't a particularly good fit, and so it's not necessarily going to be centered very well with the body of the motor. If we look at the other end, on this particular motor, the situation's a little bit better. Instead of being just a simple pressed steel piece, it's a cast and machined aluminium piece. But we can still just pull that straight off the bearing. It's not a decent fit. Also in here, one of the things that we want to avoid when we're using these motors as a grinder, there's all these holes, which is where the air gets sucked out by the fan. Remember, these motors are fitted to a consumer item, and so they're built down to a price, not up to a standard. So what can we do about it to improve it? Well, the first thing is we have to prevent the air getting sucked through, taking in those fine magnetic particles. We need to be able to mount the bearings in a more secure manner and to make sure that it's concentric with the magnets. Well, here are the pieces that I made to fix the problems with the motor as I see them. First of all, we've got these two large holes here which can allow the air in. So I've made these little shaped blocking pieces that will fit in here. I'll just put, when that welds on it done, I'll cut them to length and face that off. That cuts out one air inlet. To sort out the rest and to cure the problems with accuracy in the bearings, I've made these two bearing housings. This one goes at the back, and it's got a couple of small holes here which are drilled and tapped to take the brush holder as before. There's an insulating paper piece here, but I don't want to press anything live too tightly on that. And these, you may be able to see these fastenings for the brush holders coming through here. Now they'll be live. Now I prefer to have something more substantial than just this paper in between them. So where those live parts are, I've milled little grooves in here so that that will stand away even when the brush plate is bolted hard down onto here. So this is bored out for the bearing, which is a much better fit. The two wires, there's a double hole drilled here to put the two wires through. Now on this end, this hole where the wires come through is the only penetration. Now the wires will seal fairly well. Remember, there's no airflow through the motor because I'm not using the fan, and I'll use a little bit of gasket cement to go around here to provide a final seal on this end. So this end will be totally sealed up. It's got a nice rigid aluminium block that will take the bearing. On the other end, we had no hole cutouts on here, so there's nothing to do there. I've just made this rather more substantial block to take the larger bearing at this end, and that will fit on here. With this little spigot on the end, the pulley that I made, here's a pulley. It's going to be a press fit on there, which will take the flat driving belt. That has got a recess in here which just fits over that with a minimum of clearance. Again, these have to rotate separately to one another, so I don't actually want them touching, but it gives quite an awkward path for any dust particles to come in, and as this is spinning around quite fast, up to 5,000 RPM, that will tend to centrifuge away any of the dust particles that are in the air. This we can see here, the bearing doesn't fit in at the moment because again this needs to be heated to slip over the bearing, so much better support. Now there's one final thing with getting both of these end plates accurately centered with the magnets. The casing for the motor is just some rolled up sheet which is joined with this jigsaw effect. I don't know how well it shows on the camera. So being rolled up like that, you could hardly class this as a precision circle. So what I did here, I made up a supporting block which just fits inside the magnets with a center hole drilled in it to take a center in the lathe. This is the locating piece. It was just made out of a piece of scrap, hence these extra holes here which play no part in it. But this diameter is concentric with this drilled center. This diameter just fits inside the magnet. So I can put that in like so, put a center in here and face this off true. I then turned it around, and these magnets are set in much deeper at this end. Then when I centered it, I machined the outside true for a short length, you can see here, and also I had enough room to get a small boring bar in here, and I just took a light cut, just sufficient to touch this up all the way around so that I had a true register to fit this bearing carrier onto. That's just a slightly light press fit, so that's located extremely well. When I had it in this end, there wasn't enough room to get a boring bar up inside here to do the same thing. That's the reason that I machined the outside of this, because it then gave me a good true surface on which to chuck this up, and then holding it like that, I just took a very light cut, truing cut on the inside. That takes this block, so that was a nice snug fit, accurate fit in there. So now, instead of having this motor with the rather crummy end caps on, which weren't particularly central anyway to hold this so that the armature was central in the magnets, I've got a much more accurate location for the armature. I've got good fits on the bearing, which just require me to warm this a little bit to slip it over during assembly or disassembly. And in addition, it's sealed extremely well. It's mainly just this shaft, the driving part of the shaft on the motor, where there's any sort of connection to the outside air. But that part is very, very small, and it's a shielded bearing as well. Well, we'll come back to that motor when I've finished all the work and fully assembled it. In the meantime, let's have a look at this other motor which I'd already modified. Now, the same considerations apply as far as the fan drawing the air through, so I wanted to seal it. I also wanted to have good mounting, good and accurate mounting. We can see here, this is the equivalent of this front bearing block that I made. Here we've got the pulley, which is arranged in a similar manner to this one, where I've got this little awkward passage for any dust to get through. This was the original front bearing mounting that went on here. This was even worse than the other one, which at least was cast aluminium and machined to take the bearing. This is just another piece of pressed steel, and the bearing was quite a loose fit in this hole. This was something to get rid of. And of course it also had these holes which allowed the fan to draw the air through. I didn't make another bearing block as I did with the first motor we were looking at. I just took this off, because instead of having a pressed steel plate like this on the end, which had the brush holder inside, the brush holder and bearing mount here were moulded in a fairly stiff sort of plastic with air holes going through here. Now this would have been, and here we've got the brush holders. This would have been a fairly difficult piece to replicate in aluminium, and it was a reasonably good fit on the bearing and not too far out as far as accuracy was concerned. It was reasonably well centered over the magnets. So I decided to keep this end piece, but I needed to block all these holes up. Various options occurred to me. I thought of perhaps squirting some foam in or something like that to block them here. But in the end what I did, I just made this simple cover, these cutouts that go around the brush holders, and that cover just slips over here. It comes down to where the brush holders are. It's sealed at this end. It's held on by the extension of the bolts which hold the two end caps. There's just a little bit where it's not sealed perfectly around the brush holders here, but what I'll do is just put a little bit of moulding clay around here that will provide an adequate seal, but also if ever I need to dismantle it, it will just scrape away quite easily. So that's how that one was modified, with the result that it's reasonably well sealed at each end. Here we've got a little bit of the labyrinth for it, any dust particles go through, but then the rotation of this, the pulley, will be tending to centrifuge anything away. I'll finish welding the side pieces in which block up those two big holes. So I've just put it in the mill to take a cut across the top just to true that flat again. Well, the motor housing now has got the little blanking pieces put in the two large rectangular holes here. I found because it was such a massive thing, if I just did a little bit of welding, waited for it to cool and a little bit more, then it didn't heat up the body of it too much. And I've ended up, this is still a perfect fit. This still fits fine. I'm ready now to assemble it. Now this is a case of definitely do not try this at home. I've got the motor body clamped in a 3-jaw chuck which I've got locked so that won't turn. At this end I've got the pulley fitted. I'm doing the final machining of this pulley with the spindle turning on its own bearings inside the motor. All the chuck is doing is holding the motor at the right height and right position. Is to take a cut using a normal tool in the standard tool post. So let's see how it goes. Okay, I've got the motor spinning now. This is live TV, so anything could happen. This hasn't been practiced in advance. So I'm winding in on a slight angle. The cut is just slowing the motor down a little bit because it's not running at its full speed and hence it's not developing the full power. I'm just winding it in on the compound rest, which is set to an angle of 1.5 degrees. Now the opposite angle will be at the other end from here outwards. This gives a curved surface for the flat pulley to run on, and this is essential for the pulleys to run centrally. Well, the cut on that side is finished. It's cut all the way around, so I'll now swing the compound rest around to the opposite angle and machine this side. I'll do that off camera. Well, I've now got the pulley machined on both sides. You saw earlier doing this bit. This piece has now been done, and with the aid of a file and some abrasive paper, I've smoothed off the peak at the top where the two angles meet to try and get much more of a barrel shape. So there we are. The motor's finished. The pulley will run dead true because it's been machined on the bearings of the motor itself. In another video I'll show it mounted up on the tool and cutter grinder, and we can see it in use. Well, up to now I've mainly been talking about modifying these treadmill motors for use as a grinder, and I explained the necessity for blocking off the cooling airflow that goes through. But a lot of people use these to power lathes, drilling machines, milling machines, etc. Now, in that case, the duty cycle is likely to be a bit harder. You're likely to be requesting more power for a longer period of time, and so they're going to get hot if we eliminate the cooling air. And also, we don't have the same small iron dust in the atmosphere that we do when we're grinding. So it can be much easier to modify one of these, if we're going to do anything to it, if we're using it on one of those other machines, is obviously to keep the fan that normally goes on the end here to draw air through, and whatever end caps we have on, we obviously need some holes in there to allow that cooling air to come through. However, in those situations there's still some form of swarf in the air that tends to float about, either chips or stringy bits, more stringy bits, that we don't want to get sucked into the motor either. So we need some sort of protection. So what we could do with this one, as we saw before, I've made this cover to block any air up, to seal these holes. Well, if we just had a piece of tube instead of putting an end plate on, we could put on some sort of filtering material like this mosquito net, for instance. We could put that across in place of blanking it off. Now this is just a plastic based one, which wouldn't be any good if it was hit with hot chips, but you can get metallic versions of the mosquito nets. Now something like that would apply to either of these motors. For example, wouldn't be any good on a grinder because the holes are too big to, and wouldn't stop any of the dust. Now the other things would be strictly no need to make other modifications to the motor if you were happy to use the original bearing housings at each end, because they're already there and working. But if you want to make the motor a little bit better, with better bearing supports, more rigidity, etc., which will give you a smoother running motor if nothing else, then you can still apply the modifications that I mentioned for making the bearing caps. You just have to make sure you had some ventilation holes in them. So you can see these motors are very flexible in the uses to which they can be put, and there's always room for some small improvement. If you like this video or any of the others, please share, subscribe to my channel, and don't forget to click the button to receive updates of any other videos. Thanks for watching.